So as in math class, we solve lots of problems, but are there some problems that just don't have a solution? It's true. There are a lot of problems that just don't have solutions. Math problems and real problems, right? I was gonna say real problems. Yeah. Okay, so number one, we'll start by looking at the line y equals 2x minus 5. 2x minus 5. So it says to give the ordered pairs of at least 4 points on this line. I think that's much easier to do if you graph the line first. So I want you to start by graphing this line, y equals 2x minus 5, and then list 4 ordered pairs of points on that line. And then I want you to answer that question. Is the point negative 17, negative 39? Is that on the line? Yes or no? And tell me why you think so. Okay. If you finish parts A, B, and C, then you can move on to number 2. It's not. Yes, draw that. What's the slope of that line? All right, how am I going to graph this line in number 1? Y equals 2x minus 5. How do I graph that? Yeah, why do I go to negative 5? What is it? Huh? Yeah, you're not wrong. You're right. Well, how did you know to go to negative 5 and not negative 50 or something? But you know it from where? Yeah, it's just that it's in the equation, right? It's the y, what's it called? Thank you. Thank you. Yes. So I start at negative 5. That's my y-intercept. I know from my equation. And then what? Yeah, follow the slope. So we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And I've got my line. That was really off. That's okay. Okay, can I get 4 points that are on that line? 4 ordered pairs. 0, negative 5. What else? 1, negative 3. 5, 5. One more. Good. 2, negative 1. we already graphed the line. And now, is this point negative 17, negative 39? It's not on the line, but it also is going down. So, I mean, if we wanted to think about it on a graph, negative 17, negative 39 is going to be somewhere like down there. How do you know? Perfect. So I take my equation, y equals 2x minus 5. I'm going to plug in negative 17 for x and negative 39 for y. So again, negative 39 equals 2 times negative 17 minus 5. And what I'm doing, I'm not solving, I'm checking to see, is this side equal to that side? That's what I'm checking for. So is negative 39 equal to all this? And if I hadn't done this 4 times already today, I wouldn't know what this is off the top of my head. Can we simplify this so it's just one single number? It's 2 times negative 17. Negative 34. What's negative 34 minus 5? Okay. Yeah, negative 39. Is negative 39 equal to negative 39? Yes, it is. So that tells me that yes, this is on the line. It does satisfy the equation. Okay. Okay, now we have another line. Y equals 1/2 x. And there's still a few people who were like, how do I even graph this? There's no b. What is the b in this equation? Yeah, it's 0. And like an invisible 0 there. So what's my starting point? What's the first point I should graph? 0. I forgot to start this. Oh no, I didn't. Good. Okay, never mind. Okay, 0. And then now what do I do to draw the rest of my graph? Follow the slope. What's my slope? What does that mean in terms of rise over run? Perfect. Down 1 over 2. Down 1 over 2. Down 1 over 2. And I could go back the other way if I wanted. And now I have 2 lines. Give me 4 coordinates. 4 ordered pairs of points on that line. 0, 0. What else? 2, negative 1. What else is on this line? 4, negative 2, and one more. Perfect. 6, negative 3. Excellent. Already graphed it. Are there any points that are on both the green line and the orange line? Which point? Huh? Yeah, 2, negative 1. 2, negative 1. Perfect. So 2, negative 1 would be the solution to this system of equations, right? The intersection is the solution. All right, and now let's look at this one. So I've got 6x minus 3y equals 15. What form is this kind of equation in? What form is this equation in? Standard form. Okay. So it's going to find the x and the y intercepts. How do I find the x-intercept of an equation? Yeah, make y 0. Plug in 0 for y. So I take my equation 6x minus 3y equals 15. But instead of writing y, I'm going to write 0. So now I have 6x minus 3 times 0 equals 15. What's 3 times 0? 0. So that kind of just goes away. So now I have 6x equals 15. And how do I solve for x? Yeah, I'm going to divide by 6. I'm going to get that x by itself. I got to get rid of this 6, so I divide by 6 because that's the opposite of multiplying by 6. And what is 15 divided by 6? 2.5. 2.5. So that's my x-intercept is 2.5. What is the ordered pair of that point? What is the ordered pair of that point? Perfect. Good. And then what about my y-intercept? How do I find y-intercept? Exactly. So I'm going to rewrite my equation, but instead of x, I'm going to write 0. And I'm going to solve for that y. What's 6 times 0? 0. So that goes away. So now I have negative 3y equals 15. How am I going to solve for y? Yes. So then what does y equal? Divide both sides by negative 3. So y equals negative 5. That's my y-intercept. What are the coordinates of that point? Excellent. 0, negative 5. Let's plot those 2 points. Let's plot those 2 points. So 0, negative 5, that's my y-intercept. That's right there. And then 2.5, 0, that's my x-intercept right there. What's the slope between those 2 points? How do you know that? Well, because of the equation. Yeah, it's like changing, so we can, I mean, there's a million ways to think about it, but change in y over change in x, right? So my change in y was 5. My change in x was 2.5. 5 divided by 2.5 is 2. Good. So there's my slope. And now what it is asking me, I'm going to just draw in, no, I didn't want to do that. I'm going to draw in this line between my x and my y-intercept. Now, that's really terrible, but whatever, that's okay. Purple line and the orange line, do they share any points? They share infinitely many points because they are exactly the same. They're exactly the same point. So, yes, they share all points. Right? This purple line and the orange line are the exact same line. Okay? So they are the same line. Okay, one last thing. I want to draw one line that doesn't share any points with the purple / orange line. I want to draw one line that doesn't share any points with those two. Does someone want to come up and draw a line that doesn't share any points with the purple / orange line? You can use my fancy little thing if you want. Or you can draw it on the board with the erase marker. Somebody? Anybody? Can I use this or you want to use mine? I'll use this. Do you want to change the color? Put the little color there. How do I do this? So you kind of hover over it, and that's like the mouse. And then when you want to click on something, you just touch it. Oh, okay. Let's do pink. Alright, it's harder than it looks. So draw a line that doesn't share any points with the purple/orange line. Good. Ah, you're not bad. That's pretty good for first try. Alright, there you go. That pink line does not share any points with the purple/orange line. What is the slope of that pink line that she drew? Huh? It's the same slope. So, and what are these two types of lines? Like, what are those called? Parallel, right? Parallel lines have the same slope. Parallel lines have the same slope. Good. Let's flip over to the other side. We have a few notes to take. Okay. A solution x, y to a linear system satisfies both equations. And is on the graph of both equations. Okay. So for number 1, it's going to ask you, is this point 6, -4? Is that a solution to this system? So just like we did on the front side where you plugged in 6 for x and -4 for y, and then you checked the equation to see if it's true, you're going to do that twice. So you're going to do it for the first equation and the second equation. Okay? If this point is a solution to the system, then it's going to work in this equation and that equation. If it only works in one equation, it's not going to work for this system. Does that make sense? You're going to try that. But before you do, I want to draw 3 little pictures. 3 little pictures. So a linear system can have 0, 1, or infinite solutions. 0, 1, or infinite solutions. Those are the only options for a linear system. You can have 0, you can have 1, or you can have infinity. You cannot have 7, you can't have 3, you can't have 2, you can't have 14. 0, 1, or infinity. Okay? What kind of system has 0 solutions, has no solution? Parallel lines, exactly. So parallel lines have no solutions. Right? That looks like this. Oh, that does not look parallel. That's better. Parallel lines have no solutions. What kind of system has one solution? Huh? Perpendicular, yes, but not necessarily perpendicular, right? It's just anything that has intersecting lines. That's what we'll write. Intersecting lines have one solution. So they could be perpendicular, but not necessarily. So intersecting lines have one solution, parallel lines have no solutions. And what about infinite solutions? What does that look like? Yes, same line have infinite solutions, right? And that's just our symbol for infinity. If you're not familiar with that, it's just a sideways 8, right? And that will look like this. Bless you. Infinite solutions. Okay, we've got like a little less than 15 minutes. I want you to start working on the check for understanding questions. Tomorrow is going to be mostly like a practice day, so we'll go through some of these problems, and I'll give you some time to do your Delta Math assignment. But for now, I want you to just work on numbers 1 through 3 and make sure you get it turned in by the end of class. I have to leave like right as the bell rings today, so I'm going to kind of start wrapping things up a few minutes early. Okay.